Okay, so this is a quick supplemental video that I am attaching to the original proportions video. And this is kind of in the interim for a while until I mend these two together and make them one video. So as you're practicing in your proportions packet, you probably notice that right around here, and I'm close to the end of the packet, I'm in the last 4 or 5 pages of the packet, it starts to get a little bit harder. Now, these ones on these couple of pages here aren't too bad. I'm not going to focus on them. I'm going to focus on when they get really difficult, which you noticed in the last few pages of the packet. So there's a reality to this type of question. You will get this really advanced type of question once or twice, at least, maybe 3 times. But the questions that you've practiced so far leading up to this, you will also get those questions. So you'll get a couple of easies, a couple of mediums, and a couple of really hard ones, depending on exactly how many questions, of course, you get. But proportions tends to be a bigger segment. It tends to be 5 or 6 of the questions that you're going to see. So when you see the harder problems, there's a couple of reasons that they can be harder. But what it essentially boils down to is there's something else you have to do. There's some other conversion that you have to do. And there's 2 possible places that you might have to do that extra conversion. And one of them is before you can actually do the problem. So you're trying to set up your proportion. You've got this. You've got a number here and a number here. And you have to make a conversion actually before you can even do the proportion to begin with. And then there's after, where you can actually set up a good proportion and you can solve the proportion, but the problem is that the proportion that you solve doesn't come out with the answer in the units that you need. And so this really all has something to do with units. If there's going to be an extra conversion, it has to do with units. So I would encourage you to do this one. If you've already done it, maybe just do it again just to remind yourself. Maybe pause the video real quick, do that one. I'll point out a couple of things about that one. My real target is the one that follows it. So on this first one, you notice, and I hope that you're really focused on using your words to start out your proportion problems. That's one of the things that's the easiest to sort of abandon and think, oh, no, I don't need to do that anymore. I'm getting good at these. I highly encourage you to use words and to be specific. So if I'm using words for this first question, I'm going to say meters tall over meters of shadow, because it's important that we're comparing height, shadow, height, shadow. It's also important that they're both in meters, because you can't put any other unit into this, which is the problem you run into on the next problem, is they don't have them in the same unit. So this is where you will find a discrepancy. When you write your words out, that's when you'll go, oh, crap, one of those isn't in the right word, so I can't put it in the proportion. So I'm not going to go through that first one, and you most likely have the key by now, or you will have the key soon so that you can check your answer, because the first one is not something I would consider advanced. That's a normal proportion. So you compared meters of height to meters of shadow for each of the 2 trees that you're talking about. Now, when you get to the second one, you'll see that you have a very similar problem. And again, hopefully you're using words to set up your problems ahead of time, because again, that's when you're going to go meters tall, meters of shadow. And so the first part of this problem does line up with that. 10 meters tall, 15 meters of shadow. So meters tall, meters of shadow. Now you hopefully noticed that when you get here, it says, what would the shadow measure for a tree that is 12 feet tall? We do not have a feet tall, and you could see where the problem you would run into would be if you didn't write your words out, is you may not see that feet and realize that it's a big problem, because it's a very small problem in terms of actual size. It's easy to not notice that. So feet do not go in this proportion. We cannot plug that 12 in, because then you're comparing meters and feet, and obviously those are not the same. You have to do a conversion. Now, you learned in metric how to do conversion. And if you haven't done metric yet, I would encourage you to use this as a practice for metric. So I would encourage you to do this problem after you've done metric or something like that. So if we have a tree that is 12 feet tall, we actually have 3.66 meters. And so this class is not about that conversion, but metric class is. If you're having any trouble with conversions, come to a study group and ask me about them. If you are having if you haven't done metric yet, I would skip this problem and come back to it. Just go through with me and understand what we're doing and why we're doing it, just maybe not the math. Now, what was this number? This was a height for a tree. So that was a meters tall of a tree. Now that we've got it in meters, we can put this 3.66 here. That way we're fitting our meters tall to meters of shadow specs. We put X underneath. And now we're going to be able to do our typical proportion, 3.66 times 15, and then divided by 10, and you should come out with 5.49. So if you don't have all of your ducks in a row to be able to do that, that's okay. Come back to that and come back to this explanation for that. So the next problem that you're going to run into is this one. And this is actually the opposite of what I'm talking about. So I'm not going to do this whole packet because it's crucial that you guys get all the practice out of this packet. But I am going to mention what's different about this. So this one, you would have probably written your words out as being cups of sugar and then number of people. So it's got 4 cups of sugar and 50 people. And then later it talks about 300 people. Now the question actually asks you how many bags of sugar. And you have to pay attention to the units you're being given in each area, as well as the units they're asking you for. These answers here are in bags. Well, this is the opposite conversion. I told you that sometimes you have to convert something beforehand, sometimes you convert it after. So the 3.66 meters on the last question, we had to do that beforehand. Why did we have to do it beforehand? Because it wasn't a unit that we could plug into the proportion. So we need our proportion units to match, or we can't put something in a proportion. The only thing you can plug into a proportion is something that's that unit in quantity and something that's that unit in quantity. So if you recognize that you have something that's not in the units that you've set aside for your proportion, you need to change it before you do your problem. Now on this one, you'll notice that you've got cups, people, and then people again. And so you actually need to set your proportion up as being cups to people, cups to people. So our proportion can set up here just fine. So why is this an advanced question? When you solve for X here, what type of unit is it going to spit out? When you solve for that top X, what kind of unit will you actually end up with as your answer? So it's going to come from here, right? This is going to be a number of cups. Cups is not what they asked for. However, what they asked for is bags. And the bags, the way that you calculate the bags is based on the number of cups. So it says that there's 6 cups to a bag. So this is where we can recognize this last one we needed to do our conversion before, and this one we need to do it after. So we need to find out how many cups in total in the slot that we need them. Then we can find out how many bags that would be. So we're going to go ahead and do our cross multiplication. 4 times 300 divided by 50 turns out to be 24 cups. And just make sure that anytime you're doing a proportion, especially one that looks like it's pretty tricky, that you make really sure that you know what unit you're in all the time. Make sure you've acknowledged to yourself coming out of this question that you have cups right now, not bags. Now, if sugar is sold in bags that are 6 cups, all I need to do is divide that by 6, and then I'll have the number of bags that I need, and that will turn out to be 4 bags. All of that has to do with awareness. It all starts with writing your words in before you're trying to build a numerical proportion, and then checking everything and validating that all of your words are matching up and they're truly the words that you would want and the words that you should have. Then make sure when you're coming out of a proportion, if you are able to go straight into it and you don't run into a conversion that has to happen beforehand, then you need to be a little extra careful as you're coming out to make sure that you are able to answer in the correct unit according to what they have. I'll mention something quickly on the next one. This is one of the types of questions that you will see, and they have varying fractions for them. 1.5 cups, most people know that you could switch that to 1.5. They could also do something like 2 3/8. and you wouldn't know off the top of your head what the decimal is that goes with that. The bigger concern I run into with students on a question like this is most of you figure you can't change it to a decimal, mostly because I tell you not to change anything to a decimal throughout your classes. So if you've done several classes with me, then you kind of know that I've said decimals are bad. They don't use them. They use fractions and they use mixed numbers, but they don't use decimals. Stay away from decimals. So if you've heard me say that a million times, you would be reluctant to use a decimal here. This is one place that you should use a decimal. And I'm telling you that because I've seen all of these questions. They work themselves out. They become whole numbers on their own. So in this one, you would have cups of flour and then people, number of people. You can go ahead and make this into a decimal. Go ahead and do your proportion and your multiplication, and you'll discover that although you will have to make a mixed number, that the decimal disappears. That's the important thing, and it works the same way on the weird, tricky decimals like 2 3/8. So you should always change if you're in a proportion and it looks like this. So I'm not telling you to use decimals anywhere else. I'm saying if you see a question that looks darn similar to this, then you should change it into a decimal knowing that the multiplication will undo the decimal. That does not mean you don't have a mixed number at the end. You very well may, but it will undo itself as far as you won't end up with a decimal that you don't know how to convert out of decimal. So that's the concern that you would be able to avoid. On 2 3/8, remember from Math Fundamentals how you would change that. You would take 3 divided by 8 to get the decimal part of that one. And so you'd find out that it's 2.375. So use the entirety of the decimal. When you multiply it by the number that ends up diagonal from it, it will no longer be a decimal, but you may end up with something awkward like 36/10, where you've got to make it into a mixed number. Mixed numbers are in fractions class. Very, very, very important to know how to make a mixed number, especially on the fly when you're not expecting it. There is one more that I want to look at, and that is the very last one here. You may have another page that looks kind of like that last page, and if so, then keep going on that. That's another good practice. I want to talk about this one. This one gets everybody. So I do want you, if you haven't already, and a lot of you that are going to see this class, you've done your whole packet. You didn't know I was going to be supplementing this class, and so you've probably worked these problems and already know what your question was. If you haven't worked this very last problem about the ratio of the garden being 3:4 and having a 4x10 garden, please stop, pause, and do it so that you really understand what I'm getting at, because the way I'm going to walk through this is the process you would have used and why it's wrong. So make sure that you actively do this problem now, whether you have done it before and don't remember, or whether you have not done it before. And then play when you're ready. So now I'm about to say what the process and the answer is. So you see this and you're like, all right, the ratio of a model garden to an actual garden. And so you probably did model actual as your words. And it says that the ratio is 3:4. So you probably said, all right, so 3:4. Make sure you're in order when you use a ratio. So if they say model actual 3:4, the 3 and 4 go in the same order as the model and actual went. So we have a ratio of 3/4. Now here's what happens to most people. So they see the second part and it says, if the model garden is 4 feet by 10 feet, what are the dimensions of the real garden? What most people end up doing is putting 4 and 10 both into the proportion. And of course you go, wait, there's nothing to solve for. There's no X. Well, a proportion doesn't work without an X. If you ever wondered if it would work without an X, you would now look at it and go, oh crap, that doesn't work. Because what'll happen is you'll multiply 3 times 10 and that's 30. You'll multiply 4 times 4 and you have an incorrect statement that says 30 equals 16. 30 doesn't equal 16, so that can't be the way that that works. So you have to have an X for a proportion to work. Here's what most people do after realizing that. They'll multiply these two together, so they'll make it 40. And then most people notice this is a model number that we're talking about, so they put the 40 here, and then they put the X there. This actually creates a realistic ratio. Unfortunately, it creates a realistic ratio that tells you the area of the actual garden, because when you multiplied these together, you made it into an area. And we don't know how to split that back up. So knowing an area does not necessarily allow you to know the length and the width, because there's more than one way that you could multiply up to a 40. So most people try that, and then they notice, oh crap, there's actually two answers and I only have one, and I don't know how to split this number that I've come up with to make it into more than one answer. So if you ran into those two issues, you're very normal. If you didn't do one of those two things, you're also still pretty normal. Some people just tried one of those things. So what do we really do? So the key to it is really something that I've told you about several times, and you want to keep remembering that this is a thing. You should never, ever look at your answer choices on a math test, because as you're doing a problem. So you should never look at your answers on a math test as you're doing a problem, because they're going to have decoy answers that are very carefully selected, and they are selected based on the steps that you would be taking in this problem. So as you're taking the steps in this problem, you're going to run into the other answer choices that are there. You're going to run into them as progress steps. And it would be very easy if you were looking at the answers to see the number you just came out with, totally forget you were going to do another step, pick it, and move on. So I do not recommend having an actual read on the answer choices in advance. I do not recommend that. I do, however, very strongly recommend a glance at the answers when you start up a problem or as you're nearing the end of the problem. So for example, somewhere that I've mentioned this to you guys before is you end up with something like this. And in your head, you know that this could be a decimal or a mixed number, or it could stay this way. It could stay an improper fraction. How do we know that we're not going to make a bunch of extra work for ourselves? We glance at the answers to verify what format they're in first. So if you go glance at your answers and you see that it's a mixed number, you know you're not going to waste 5 minutes making it a mixed number, because that's what you need. So always look, and I call it glance for formatting. Always glance when you come to a point in a question where the way in which the answers are written might be relevant. They're not going to do a couple of improper fractions and a couple of mixed numbers. They could be a worser, meaner test than they are, and they could do that, but they don't. They stick to one format. So you can very literally glance at the answers without seeing anything numerical, without seeing what the number actually is. You could glance at your answers and go, oh, this is going to have two answers, or this is going to be a mixed number, or this is going to be a decimal, and it saves you from going the wrong route. In this case, it might help you gain some clarity as to why your first two attempts at solving this have not worked. There's two answers. There's two things here, and there's two things here, because we're literally talking about a length and a width. So what you have to do is you have to elaborate on your proportion. So I'm going to move my 3/4 over. You need to do a model length to actual length, and you need to do a model width to actual width. It doesn't matter which one's which. All I'm pointing out to you is you need to do a separate problem for the 4 and the 10. You can't combine them together. There's not a way to put them together. So you need to do one problem that's for the 4, one that's for the 10. The comparison, however, is the same, which is why I'm still doing this that I was doing before, but I'm adding that we're comparing one of the particular sides. So let's say that we're going to call 4 the length and we're going to call 10 the width. If you like the length to be the longer one, you can do it oppositely. It does not matter. You see that the answer doesn't say length width. So as long as you know what you're doing with your numbers, you're fine. So if we plug the 4 in, the 4 corresponds to the model. So the 4 needs to be the top number. What we don't know is the length of the actual. Now down here, we need to do the same thing. And then the 10 is the width of the model, and the X is the width of the actual. So you need two totally unique problems. How do I know this? Because there's 2 components given, and then there's 2 answers. So when you multiply this out, you'll end up with 16 over 3 and 40 over 3. Go ahead and do those mixed number conversions. I want you to practice that as often as possible. I literally won't tell you what the answer is. Here's the one more thing that I'll mention. Your answer needs to go in order. How do we know what's in order? Most people instinctively get this correct, but it's all luck, and I want it to be more than luck. What order does our answer need to go in? The answer that corresponded to the 4 needs to be the front one. The answer that corresponded to the 10 needs to be the back one. Now you see that they're in mixed number format. So I'm just going to use the impropers for now. The answer that we got with the 4 was the 16/3. So you would need it to be in the front ahead of the X. And the X means by. That's like saying a 10 by 12 room. The little X sign is a by sign. So we have 16/3 by 40/3. You need to make those into mixed numbers, but we don't switch their order. We would assume the answer is going length width or width length, whatever you called it, in the same manner as this. So keep them lined up with the dimension that they went with. So 16/3 goes with the 4, 40/3 goes with the 10. Make sure they're in that same order, because if you switch the order, you're comparing a length to a width and you're comparing a width to a length. And then that proportion is not accurate because we know that they have a different ratio. So there are several other advanced proportions. By now, you either have the key or you're about to obtain the key from me. So keep this in mind as you're working your proportions. I'll also be doing a supplement for advanced percentage applications for some of those ones on the back that have the graphs. Add this into your regime. So when you run into a proportions question, when you do your mock testing or whatever you do from here, when you run into this, make sure that you have an assessment that goes on where you make your words and then you determine, do I need to convert anything? And if I do need to convert something, do I need to do it beforehand or do I need to do it after the proportion? And that all has to do with, do the units line up to where you can use the proportion, or can you not yet use the proportion? And then when you run into something really weird like this last one, this is the worst case scenario. This is the absolute hardest it could get. Make sure you're looking at things like answer formatting and thinking outside the box a little bit to make sure that your answer lines up with ultimately what they did. If you have more questions or you have a problem that you get stuck on, that's what study times are for. So let me know if there's something that you want me to work with you, or if there is a general concept you're having an issue with. This is the last of proportions, so that would mean you're most of the way through the packet, other than your own practice that you'll continue to do. That is it. I will see you guys later.